All right, so it wants you to find the magnitude of the total force on the particle that's charged on this one. I called the one on the left particle 1, this was particle 2, and this was particle 3. So anyway, you can see that because these are both positive, this is going to repel it. This particle 1 is going to repel particle 2 in this direction, so it's going to repel it up and to the right. And since these have opposite charge, this particle 3 is going to attract particle 2 down and to the right. So because these two charges because particle 1 and particle 3 are the same distance and the same like net charge, and they're the same distance away from particle 2, they're going to have the same net force on it. So that means that because the force of particle 1 is going to push it up, and the force of particle 2 is going to bring it down, and they're going to have the same net force in the y direction. That means that you can basically just negate the y direction because it's going to be 0. But because they're both pushing it to the right, they're going to push it to the right. They're both going to push it to the right. So you have to find the force in the x direction, and that would be your net force. So the first thing you're going to want to do is find the net force, and then you can solve for the x component of those net forces. So first, let's find the net force of particle 1 on particle 2. Which you should find to be is 1.8 times 10 to the negative fourth. And then what you want to do is you want to create a triangle that has the net force vector and then just the x component and the y component. So like this would be the net force, and then you just create a right triangle and it would be like that. So this is the net force here, this is the y component, and this should be the x component. And then so this is the net force, so it's just going to be 1.8 times 10 to the negative fourth. And then this should be the force of particle 1 on particle 2 in the x. This should be the force of particle 1 on particle 2 in the y. And then basically, and then this angle is 60 degrees. And so then basically what you're going to want to do is you're going to want to figure out the x component, because remember the y component is going to be, it's going to total to 0, so we don't have to worry about the y component. So you want to find the x component, and the way you're going to do that is you use the cosine function. So because cosine is going to be, cosine of theta is adjacent over hypotenuse, and this, so the adjacent would be the x component, and the hypotenuse would be this. So we have cosine of 60 degrees equals f x component over 1.8 times 10 to the negative fourth. All right, and then so this is adjacent over hypotenuse, and then you just want to use algebra to solve for the x component here. So the x component is going to equal 1.8 times 10 to the negative fourth times cosine of 60 degrees, and then you would just solve for the x component, and you should end up with, I think it's 9. No, hang on. Yeah, it should be 9 times 10 to the negative fifth. And normally what you'd want to do is so this should be the x component of the force of particle 1 on particle 2. And normally what you'd want to do is you'd then, and because it's going to the right, it's going to be positive. But yeah, you would then want to find the x component of the force of particle 3 on particle 2. in then you'd want to subtract, and then you'd want to add them together. But because we know that the forces are gonna be the same, because again they're both the same distance away from particle 2, and they have the same like net charge. It also means that the forces in the x direction are going to be the same as well. So you can basically just multiply this by 2, and that would be your answer, because what you would end up doing is you would get the same number for the x component of the force of particle 3 and particle 2. You'd get the same number, and then you'd add it together, and then that would be your answer. So if you multiply 9 and times 10 to the negative 5th, you multiply that by 2, and you're going to end up with 1.8 to the times 10 to the negative 4th, and that should be your answer to number 5, to part A. Part B is asking the direction, which we already figured out. It's going to the right, and that's how you do number 5.